Hey guys, welcome to Unit 13, Lesson 1, Parametric Equations. I want you to pause the video and then we will analyze what's written down below. Okay, so let's take a look at this. It says, imagine hitting a golf ball and watching its flight path until it lands. We can write rectangular equations that model the height of a ball as a function of the distance traveled, but often we are interested in analyzing each of these separately as a function of time. Yes, that's what it's saying. So let's say if we were to sketch it, my graph would look like if I had a golf ball. At time 0 I'm hitting it, it'll go up and then it'll follow like a parabolic path, something like that, right? And then it'll hit the ground again here. So it's saying the height of the ball, this would be h of t, right? And this one would be my distance. My distance, how much distance did it travel? And I actually want to write not h of t, I want to write height. This is my height of the ball, right? So if my ball is here, I'm going to say, I'm going to take a different color. This is the distance that it traveled, and that would be the corresponding height, right? So to do this, we would need two separate equations, one to model the height of the ball, call it y as a function of time, and another to model the distance the ball travels, call it x as a function of time t. This is the idea behind the parametric equation. So what it means is, if this is my distance d, this horizontal one is my distance d, and this vertical one is my distance h, or that's the height, that could be happening at, let's say, time 3. What's happening at time 5? It's going to be somewhere here, let's say, right? But that is the reason why we need to introduce a third parameter, time, so that we can find out what height is it. If I don't want to know the distance, I want to know at time 3 what is my height of my ball. And or I want to know at time 3 what's the distance and the height, how far did it travel. And that is where the need of a third variable comes into existence. So this is the whole idea behind parametric equations. In general, parametric equations are a pair of equations that involve a third independent variable, which usually represents time. Both x and y are now dependent. So t is independent, right? Because based on that we tell at what height the ball was and how much distance did it travel. Okay, so let's do some questions and then this will start making sense because you'll see actual equations. So a particle moves through the xy plane. Its position given in time in feet at time t seconds is modeled by the equation below. Without a calculator, make a table and sketch the curve the particle follows, indicating that its direction. So here, and then eliminate the parameter. This is part 2. This is B. I first need to work on this. Okay, so if you look at this, you have two equations, x and y, and they both are depending on time t, right? So what you do is, how do you set up a table? First of all, look at your t. Your domain is restricted. So you're going to set up a 3-column table, which will have time, then x and y. So your time is from -2 and 3 included. So all these numbers, -1, 0, 1, 2, 3. And then corresponding to it, how do I find these x and y? So if I substitute in -2 here, -4, what do I get? 0. So I'm going to start substituting my t values in for x and I will get these numbers. I'll get -3 if I substitute -1. I'll get -4 here, -3, 0, and 5, right? Similarly, I'm going to substitute my t values in my second equation and I'm going to get my y. So if I substitute -2 divided by 2 is -1. This would be -1/2, 0, 1/2, 1, 3/2. Right? So this is what it is. So now it actually asked us to make the table. So we made the table, sketch the curve. So now when we're sketching the curve, guys, we have to consider our xy coordinates only. We're going to just talk about these. Because remember, we want our parameter is t. We want to eliminate it. So we want our equation only in x and y. So just as you would plot points, 0, -1, which, I want a red pen. 0, negative 1. Then I have negative 3, 1, 2, 3, and a negative half. That would be here. Negative 4, 0. 3, negative 3, and positive half. 0, 1, and 5, 1, 2, 3, 4, 5, and 1. And it's going to be solid dots because it's a restricted domain, and I'm going to connect it. I'm going to connect it in the same order I graphed it. Okay, and I'm going to put arrows also because I need to show my direction of the particle or whatever this thing is, right? Oh, it is a particle. It says moving in the xy plane. So that's how you do these equations. So now part B is telling me eliminate the parameter. Eliminate the parameter means get rid of t, write your equation, in terms of x and y. That's what it means. Okay, so we have to know the language. So what do I do is I'm going to take one equation, whatever, doesn't matter. You can pick the first one, but the second one looks easier. So if I solve it for t, do I get, it's y equals t over 2. I'm going to cross multiply, I get what? T equals 2y. So I'm going to take this and substitute into my first equation. So x equals 2y squared minus 4, and I'm going to solve for y. So it will be x plus 4, added 4 on both sides, equals 4y squared, divide by 4, so I get y squared equals x plus 4 over 4. Take the square root, and when you take the square root, don't forget the plus and minus. So y is equal to plus and minus x plus 4 over 4. You don't have to simplify it. You can just leave it in that form. So this is your final equation. So you eliminated the parameter and you wrote the equation. You don't have in terms of x and y. So this is how you do these questions. Example 2. So again, it's saying do the same. So basically we want to graph it and then eliminate the parameter. So we're doing two things. So to graph it, we're going to set up a 3-column table with t, x, and y, right? So I'm going to just take values for, it says t is greater than or equal to 0. So 0. Okay. So here, okay, I'm going to be very careful. Look at the first equation. You don't want values that have radicals. So you want to pick t values that make it a perfect square. What are perfect squares? Numbers like 1, 4, 9, and 16, right? So what t, so I'll basically take a number less than those perfect squares because plus 1 will give me a perfect square and then I can square it root. So the first number is 0 plus 1 is 1. The next one would be what? 3. Right, so what happens? Let's substitute and show it to you. So if I do 1 plus 0 plus 1, I get what? 1 over square root of 1, which is just 1. Similarly, if I do 3 in here, I'm just going to substitute 1 over 3 plus 1. It'll give me square root of 4, which is just 2. So that would be 1/2. Then I'm going to take, I'm actually do this. What would be the next number? I'll take 8. It doesn't really affect this equation because it has no radicals, but it wouldn't be wrong if you took those numbers, but then you had to approximate them. And remember, we're doing this without the calculator. So you want to be very wise with the choices that you pick for your t. So this would give you 1/3. Then I would say the next number would be 15 because your next perfect square is 16. So 1 less would be 15. 1/4. And then 24 will give us 1/5, right? I'm going to take these numbers and I'm going to substitute in this. So I'll do the first one for you and I'll show it to you. So it's 0 over 0 plus 1. 0 over anything is 0. So my first number is 0. I'm going to do a different color. 0. This was 1/2. So then I'm going to take 3. It'll be 3 over 3 plus 1, which is what? It's just basically your denominator is 1 more than the numerator, right? So can I just not do that? So if it'll be 8, it'll be 8/9. This would be 15th, 16th, and 24th, 25th. Do you agree? All these numbers are less than 1. Even if I tried the next number, 35, I would still get 35 over 36. Which is again a number less than 1, and so on. No matter what number I try, it will always be less than 1. So let's now graph it. So let's see, the first point is 1, 0. Remember again, I'm going to highlight this. We are graphing our x and our y's. Okay, so let's go. 1, 0, I'm going to actually scale it. This would be 1 and this would be also 1, right? This is my x-axis, this is my y-axis. So 1, 0, that would be my first point. Then a half and 3/4. So this was a good half and 3/4. So that would be just like here, right? Then I have what? 1/3, which is this point, 1/3, and 8/9, which is what? A number less than 1. Right, so I'm going to just do it here. Then I have 1/4, which is less than a third, 1/4, and then a number again less than 1, 15, 16th. So do you see how my numbers, my x are getting closer to 0 and my y's are getting closer to 1 and 1? So that's basically, if I was to sketch it, this is the direction my graph is going in, right? And what happens, it'll never get to 1, so I'm going to actually put a hole at 1. It's not a solid circle, it's going to be an open circle, because no matter what value I pick, my graph will get closer and closer to 1 and it'll never touch it. Okay, so now let's eliminate the parameters. So these are the few things that you need to pay attention to. So how do we eliminate it? I always said take one equation. Does it matter which one would be easier here? The first one could be easier. I can square both sides, right? And I get what? X squared equals, you can start with the second one also, it won't really affect, but I think the first one would be much easier. So 1 squared is just 1, and the square would cancel out, so I'm left with t plus 1. I want to solve for t. I'm going to cross multiply. I have x squared times t plus 1 equals 1. Divide by x squared, I have t plus 1 equals 1 over x squared, and then t is equal to 1 over x squared minus 1. I'm going to take this and I'm going to substitute in place of t here in the second equation. You can try it the other ways also. It's just, there's no set way to doing it. Sometimes it's easier to work with your radical equations or square root, depending on what it is. And it's just like a matter of your preference. As long as your work is right, it really does not, you won't get points taken off. So I'm going to do the other one. I'm going to substitute t in there, 1 over x squared minus 1, and then 1 over x squared minus 1 plus 1. The ones cancel out, that's nice. So if I do the numerator, it's what? 1 minus x squared over x squared, and all over 1 over x squared. And I'm going to do keep, change, flip. What happens to my x squares? They actually cancel out, and I'm left with just y equals 1 minus, well, that came out to be a very nice looking equation. And just think about it, if I was to graph the remaining of the particle, doesn't it look like it's going down? It's an open down parabola, which we're not doing it, but I just wanted you to get an idea. And look here, this is a quadratic and your leading coefficient is negative. So if I was to rewrite it, it's negative x squared plus 1, right? And it shifted up 1 unit. So kind of that makes sense, that you know what this equation is and what your graph would look like. You can kind of predict from there. Okay, so example 3. Again, I'll encourage you to pause the videos and try them. So do the same thing for t equals, this should be x equals. There's an x missing in here, so please put that. X equals y, 2 plus 3 cosine t, and y equals negative 1 plus 2 sine t. So now what are we going to do here is we are going to set up a table. We're doing the same thing. We're graphing, and then we are going to eliminate the parameter, which is t, happens to be in this scenario, right? Now be very careful. Our domain is restricted from 0 to 2 pi. I'm going to change it from 0 to 360 degrees, right? And both included. So what values would I pick that I get a nice, like my cosine graphs, I don't get irrational numbers, right? So I'm going to pick my quadrantal angles. That would actually be really nice to do. So I'm going to start with 0. So what is it? 2 plus 3 cosine 0. What's cosine 0? Again, I'm going to quickly sketch you your unit circle. This is 1 0, 0 1, negative 1 0, and 0 negative 1, right? This is 0 degrees, 90 degrees, 180, and 270, and again 360. Okay, so cosine 0 is 1, so 2 plus 3 is 5. It's gonna be 5. What's the next t value should I pick? I'm gonna go in, I said I'm gonna pick my quadrantal angle, so it'll be what? Since your domain was in radians, I must write it in radians. So this is pi over 2 I'm gonna pick. Then I'm gonna pick pi, which is 180. Then 270 is 3 pi over 2. And then lastly, it's 2 pi because it said 2 pi is included, right? So now let's substitute it. Cosine of 90 is 0, so this would be just 2. Cosine of 180 is negative 1. So it'll be 2 plus 3 times negative 1, which is negative 1. And cosine of 270 is 0, so it's again going to be 2. And then 2 pi, same thing as 0, so it's going to be 5. Okay, so now let's talk about y. I'm going to substitute in y. So negative 1 plus 2 sine of whatever that angle is, sine of 0. So sine of 0 is 0. So it's going to be just negative 1. Sine of 90 is 1. So this would be 1. Sine of 180 is 0. So this would be again negative 1. Sine of 270 is negative 1. So it'll be negative 1 plus 2 times negative 1, which is negative 3. And then the last one is sine of 2 pi, which is same thing as sine of 0, so it's going to be negative 1 again, right? So we got our table, and let's graph this. So it's 5 negative 1, 1 2 3 4 5 negative 1, 2 1 2 1, then I have negative 1 negative 1, 2 negative 3, right? And 5 negative 1 will end up with the same point. Look at this. What does it look like? It's close to circle, but since it's not evenly distributed, and that would be my center, right? So this is the path it's following. It is actually an ellipse. Okay, so how do I eliminate the parameter? So now we're going to work on the second part of the question, that is to eliminate the parameter, meaning get rid of t and have our equation written in terms of x and y. So what we do is, since it's a cosine graph, we actually end up using one of the trig identities, which I'm going to write here. Sine square t plus cosine square t is equal to 1. Right? So make sure we have our equations as sine square and cosine square. We want them by itself. So let's take the first equation and solve for it. So I'll get x minus 2 equals 3 cosine t. I'm going to solve for cosine t. What do I get? X minus 2 over 3. I'm going to square both sides because remember, in my identity I have cosine square t. So this is cosine square t equals, I'm not going to expand this, I'm going to leave it as it is. I'll just square the denominator. Similarly, I am going to do my other equation. Y plus 1 equals 2 sine t. Divide by 2, I have sine t equals y plus 1 over 2. And if I square both sides, again, y, because my identity has sine squared t, so it'll be what? Sine squared t equals y plus 1 over squared over 4. Okay, all I'm going to do is now substitute in here. I'm going to switch my color. So in place of sine square, I'm going to write y plus 1 square over 4 plus cosine is what? X minus 2 square over 9 is equal to 1. And that is actually the equation of this graph, which is the equation of an ellipse. It means what? This actually tells you that this is your center. So I actually have it written backwards. I'm going to rewrite it so that way you know this is your x and that's your y. So it's the horizontal shift happening, right? So your x is 2 and y is -1. So isn't your center 2, -1, right? And these numbers have to do with your major and minor axis. 9 is your major axis. Square root of 9 would be. So this is, look, this is 3 units. And that is 2, which is square root of 4. So in this example number 3, we made use of the trigonometric identity. What was the trig identity that we used here? Was sine squared theta, or sine squared t, plus cosine squared t is equal to 1, to sketch an ellipse. So which trigonometric identity would you use to obtain a graph of a hyperbola? Think about it and we can have the discussion. Anyways, finish the remaining lesson for homework. Good luck, guys.